Hello, 5th primary student. Today is the first math lesson in the second semester under the supervision of the Ministry of Education. أهلا بكم طلبة وطالبات الصف الخامس الابتدائي في أول درس لينا في الترم الثاني تحت رعاية وإشراف وزارة التربية والتعليم. Our first lesson is set of natural numbers. Today we will learn about the types of numbers that we have, counting numbers, natural numbers, and what are they. So here I'll start with the set of counting numbers, or the C. We refer to it with the letter C. Now if I have some students in my class and I want to count how many students do I have, how do we count them? Or what is the number that I start counting by? Of course I start by 1. So I count 1, 2, 3, and so on. These are called the set of counting numbers. When I start to count using the first number 1, then this is called the set of counting numbers. Now, the set of counting numbers is C, capital letter C, because it's a set, equals to braces. When I am dealing with a set, as we said in the first term, we use the braces. So inside the braces, I write down the elements of my set, which are 1, 2, 3, 4, 5, and so on. Okay? Here, as you see, the first element that we have in the set of counting numbers is 1, and this set has no end. And as we said in the first semester, that if I have a set and this set has no end, this means that this set is an infinite set, or a set that has no end. It will never end. Okay? So here the counting numbers, or the set of counting numbers, is an infinite set. Okay, now I'll move to another expression or another term, which is the natural numbers, or N. I refer to the counting numbers by C and the natural numbers N. So here, if I said that my counting numbers is the elements, or the set of elements 1, 2, 3, 4, and 5, there is only one difference between the set of counting numbers and the set of natural numbers, and this difference is the digit 0, or number 0. Okay? So here, if I have a 0, then the counting numbers, or C, is going to be turned into N, or set of natural numbers. Okay? Then the set of counting numbers is the set of elements 1, 2, 3, 4, 5, 6, 7, 8, and so on, while the set of natural numbers is the same. I will add only a 0 to it. So here, when a 0 is added, to the set of counting numbers C, we get a new set of numbers, which is called the set of the natural numbers, or N. The set of natural numbers, or N. So I mean that N is the set of elements, or the set of numbers 0, 1, 2, 3, and so on. So it's also an infinite set. So it is also an infinite set. So let's see how it looks on the board. Okay, dear fellows, now I will let you see how the set of natural numbers and counting numbers look like. So here, if I have This is the set of counting numbers, so it is 1, 2, 3, and so on. This is, as we said, is the set of counting numbers where I count things with. And pay attention, I don't use fractions or decimal numbers while counting or using the set of counting numbers. This is not correct. I have to use a whole number. I never use fractions or decimal numbers. These elements, they don't belong to the set of counting numbers. So now, if I want to change this set of counting numbers into a set of natural numbers, this is what I am going to do. I'm just going to add a 0, okay, to it. So I have here in pink the set of counting numbers where I count things or people. Of course, I don't have half a person or quarter a person or anything of this. So here I count in whole numbers, and I start counting by 1, 1, 2, 3, 4, and so on, because as we said, this is infinite set. Then if I want to turn it to a set of natural numbers, all what I need to do is to add a 0 to it. Okay, let's go back and finish our work. Okay guys, now let's start to practice on what we have discussed now. But first we have something or some remarks that I need you to know. First, the natural numbers. As we said, natural numbers are counting numbers or the set of counting numbers union 0, which means it's the set of counting numbers plus 0, or I'll add to it a 0. Now, n difference, the set of 0 is equals to counting numbers. They are both the same, of the same meaning. Now, the counting numbers, the set of counting numbers is a subset of the set of natural numbers, which means it is a part of the natural numbers. But the opposite is not correct. The natural numbers, the set of natural numbers is not a part of the set of counting numbers. We need to remember that both C and N, both the set of counting numbers and the set of natural numbers, both of them are infinite sets, which means that they have a beginning but they don't have any end. And we have to remember that 0 is the smallest natural number. 0 is the smallest natural number, while 1 is the smallest counting number. Okay? Now, these are some of the facts that we need to know. I'll add only one to them, which is the one that I have just told you about, is that natural numbers and counting numbers, they have to be whole numbers. They have to be whole numbers. I cannot use fraction or decimal numbers in this case. Okay, now let's practice. The first question, number 1, the set of numbers 0, 1, 2, 3, and so on is what to the set of counting numbers? Let's remember together. When I have a relation between two sets, I choose either subset or not subset. And when I have a relation between an element and a set, I use either belong to or does not belong to. So here in the first question, we have a relation between two sets. Then I have to choose either subset or not subset. Okay? So here 0, 1, 2, 3, or the set of numbers 0, 1, 2, 3, is it a part of the counting numbers? No. Why? Because I have 0 here, and the 0 or the element 0 is not a part of the set of counting numbers. Then in this case, it is not subset. Now I'll move to the second one. The set of numbers 1, 2, and 3, and so on. Is it a part of the set of natural numbers? Here it's a relation again between two sets, so I'll choose either subset or not subset. And if you look here, we'll find that 1, 2, and 3, these numbers are part of the set of natural numbers. Even if I don't have a 0, even if I don't start with a 0, but still these 3 elements or these 3 numbers are a part of the set of natural numbers. So this one, yes, they are subset, or this set is subset of the set of natural numbers. Now, number 3, 2 over 3. Here, first it's an element. Then here I will use either belong to or does not belong to, because this is an element and a set. Now I need to see if it belongs or does not belong to n. Before I decide, let's first look at our fraction. Can we simplify it, or is it in its simplest form? Before I decide, I have to simplify my fraction into its simplest form. But here this one is already in its simplest form, so it will remain fraction as it is. And in another question, I'll tell you why we are going to simplify it. Okay? So here, 2 over 3, it does not belong to n because, as we said before, it is a fraction. So I cannot take it as a natural number. So this does not belong to. Number 4, 5, is it a part of the set of natural numbers or not? If you remember, we said before that phi is a subset of any set in the world, while not every set is a subset of y. Okay, so here phi, a set of natural numbers is a set, relation between two sets, then I'll use subset or not subset. And as we said before, phi is a subset of all the sets in the world. So it is subset. Here, question 5. Remember what I've just told you about the fractions. When I have a fraction, I have to make sure that it is in its simplest form. So here, 15 over 3. Can we simplify it furthermore? Yes, of course, because they have 3 as a common factor. So if I divide the 15 by 3, it will be 5, and if I divide the 3 by 3, it's going to be 1. So 5 over 1 is 5. Oh, it gave me a whole number this time. So I cannot consider it as a fraction after all, because it gave me a whole number. Then now it is in the set of natural numbers n. It is in the set of natural numbers n. So the 5, an element, and it is a part of n, so it belongs to n. Now, number 6, I have 2 sets union to each other, and I want to see if I get their answer and see when they are union to each other what answer I get. Are they a part of n or no? So here, the set of elements 6, 7, and 10 union the set of elements 10 and 11 equals the set of elements 6, 7, 10, and 11. Okay, this set, is it a subset or not subset of n? It is, of course, subset of n, because all of the elements are whole numbers, and we said that the whole numbers starting from 0 till eternity is a part of n. Number 7, 3.5. here we have a decimal number. And as we said before, fractions and decimal numbers are not a part of n, so it does not belong. It does not belong to n. Now I will show you some facts, few things which are subsets of n. So the first one here, the set of natural numbers, as you see in front of you, the counting numbers are from 1 till eternity, infinity, and the set of whole numbers, it is the same as natural numbers. So whole numbers and natural numbers are the same. So it starts with 0. Now the set of even numbers and the set of odd numbers, I'm just reminding you of odd and even numbers. As you see in the trains in front of you, the first train is even number, 0, 2, 4, 6, 8, 10, 12, and so on. And the set of odd numbers, as you see, is 1, 3, 5, 7, 9, 11, 13, 15, 17, and so on. And of course, all of them are infinite sets. Now, the set of prime numbers, do you remember what we said last year about prime numbers? We said that a prime number is a number that has only 2 factors, a number that I can divide it by 1 or itself. So it's here 2, and remember 2 is the only even prime number. 2, 3, 5, 7, 11, 13, 17, and so on, and it's also an infinite set. Now, here if I have this question, the set of even numbers, the set of odd numbers, and the set of prime numbers, let's go to the board and answer this question. Okay, now if I have, as I said, the set of even numbers 0, 2, 4, 6, and so on, set of odd numbers 1, 3, 5, 7, and so on, the set of prime numbers 2, 3, 5, 7, and so on. Then I want you to find the following. The first question, the set of even numbers is union odd numbers in what? So the set of even numbers is union odd numbers in n, okay? And then the second question, the set of even numbers intersects 0 in what? So it intersects odd numbers in what? The set of even numbers intersects the set of odd numbers in phi, because they never meet. The even numbers are totally different than the odd numbers, so they never meet, they have nothing in common, and that's why the answer will be phi, or an empty set, or nothing. Now, the set of natural numbers intersects the set of prime numbers in all the set of prime numbers, because all the prime numbers are part of n. So they intersect each other in the set of prime numbers. Okay? Here, number 4, the set of even numbers intersects the set of prime numbers in what? As we said before, we have here the set of prime numbers 2, 3, 5, 7, and so on. We said that we have only one even number in the set of prime numbers, which is 2. Then the set of even numbers intersects the set of prime numbers in one element only, which is here 2. So it is the set of the number 2. Now, the last question, n difference the set of even numbers in what? N difference the set of even numbers in what? It's difference the even number in 0. Okay, now let's go back and finish our work. We have here a new question, which is put true or false, or put tick or cross. Okay. The first question that we have is the weight of anything in kilograms, does it belong to N? Of course not, because sometimes we have half a kilo, quarter a kilo, 2/3 of a kilo. So here we have fractions or decimals when we weigh something. When we weigh something, sometimes I get a decimal number or a decimal weight or a fraction of a kilo. So it's wrong. It does not belong to the set of natural numbers. Now, letter B, your cell phone number, our mobile phones, okay? The numbers of our mobile phones belongs to N or no? Of course, no one of us has a decimal number in its cell phone. I mean, your number is always 0, blah, 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 and so on, without any decimals or fractions. So here, yes, it belongs to N. The number of pages of a book. You never find in your book the page 1.5, 7.5. We always have them as whole numbers, 1, 2, 3, 4, 5, and so on. So of course the number of pages of a book belongs to N, so it's tick. Now letter D. The smallest prime number is 1? Of course not. We said before that our smallest prime number is the only even number that we have in the prime numbers, which is 2. Here, letter E. The set of the element 0 is a subset of the counting numbers. The set of element 0 is a subset of C? Of course not. We start the set of counting numbers with 1. So this is wrong. Okay, now letter F. The set of elements 5 and 8 intersects the set of elements 4 and 9, subset N. Let's see here. 5 and 8 intersects 4 and 9. Okay. In what? They don't meet. They have nothing in common. So they meet in nothing. So the answer is phi. And phi is a subset of any set. So this is correct. Now letter G. The set of elements 3, 4, 5, and so on till 100 is a subset of N. Yes, because all the whole numbers are part of the set of elements N, or the set of natural numbers. So this answer also is correct. Okay, dear students, that's all for this part of our new lesson, and we will meet once more to learn more about this concept or this lesson. It was good to see you again. See you again. Study well. Bye.